Hello, I'm Chris Kott.
I'm Zachary Meyer.
I'm Lincoln Schroder.
I'm Nick Tiede.
And today we are presenting on our research topic, applying counterfactual inference using predictive models to determine alternative course sequences for helpable students. Advanced slide.
About half of all students in the computer science and software engineering department struggle at some point in their academic career. These struggling students have a GPA of less than 2.0 or receive less than a C- in a course. Students and advisors have a hard time trying to figure out the best course of actions to help these students succeed. Our research questions are there common course sequences between students? Can we determine possible alternative sequences? How accurately can we predict alternate course sequence grades? And how many struggling students are helpable? A student is considered helpable if we predict a GPA improvement through course sequence intervention. Advanced slide.
For our research, we use a data set of past students who were in the CS/SE program between 2013 and 2018. And we wanted to see if students would do better on a different course sequence by applying counterfactual inference. Counterfactual inference is when you want to see what would happen rather than what did happen. An example is what would happen if a software engineering major changed to a computer technology course sequence. We would not be able to use a randomized control experiment, as we cannot go back in time to change a student's course sequence to view how they would have done. Therefore, we use predictive models to determine the grades of the students on the alternative path. Since both course sequences have common courses, we can use those to base our predictions for how they would have done. Some of the predictive models we used were new support vector regressor, Bayesian network, and random forest regressor. For these models, we could train on the course grades of all computer technology students prior to the course sequence divergence, then test on the software engineering students whom were dismissed.
For our results, of the original 349 struggling students in our dataset, we found that 146 students never graduated or switched majors. Of those students, only 17 of them were eligible for switching majors, and only 14 had enough data to be used in our predicted models. For a student to be eligible, they must have passed a minimum course requirement to start another course path. For example, Object-Oriented Programming and Data Structures is a course required for all CSSE majors, so if a student did not pass that course, they wouldn't be eligible for any alternate paths. Students who were only at the university for 1 or 2 semesters are also not eligible due to lack of data. Our results showed that switching to computer information systems is highly effective for struggling students, but switching from software engineering to computer technology is a less effective switch. All 14 of the students we tested were predicted to graduate with a GPA greater than 2.0 on the alternate path given.
The bottom images show the performances of our chosen grade prediction models. Our chosen models include new support vector regressor, random forest regressor, gradient boosted trees regressor and classifier, logistic regression, and a customized Bayesian network created by Nick, as well as 2 0R baseline models for comparison. 0R means 0 rules, and it does not predict on any of the features, which is why they are used as a baseline. On the bottom left is our error chart. Normalized root mean square error, or NRMSE, is our primary evaluation metric. It is calculated on a 0 to 1 scale, with lower numbers being better. On the bottom right, we have our accuracy chart. We analyzed each model on a plain prediction accuracy, accuracy within a half grade, for example, a B prediction within B+ to B-, and accuracy within a full grade, for example, a B prediction within A to C. As you can see on both charts, new SVR and random forest regressor performed the best at an almost tie, followed very closely by our noisy average Bayesian network.
We made a diagram that we can pull up here. And this diagram represents all the common courses we found in our data set, with the thickness of the lines representing how many students took that path. We also found that using this chart, we can determine alternate course sequences for students, but only if they were already following one of the paths listed. The models used can usually predict within full letter grade accuracy around 85 to 90% of the time. And for our conclusion, For the struggling students that are helpable, we haven't fully tested all struggling students, but we found that almost 10% of dismissed students are helpable and could potentially see a final GPA of 1.0, increase of 1.0.
For future work, we want to see if adding non-prereq courses to our models can help get more accurate predictions, look into how course retakes can affect our predictions, and look for course sequences that can reduce time to graduate. We also want to create a recommender system that builds on last summer's system that advisors can use to help real students.
We would like to acknowledge funding from the following sources: the UW-Platteville Summer Undergraduate Scholars Program, the UW-Platteville College of EMS, the UW-Platteville Scholarly Activity Improvement Fund, and the UW-Platteville Computer Science and Software Engineering Department. Thank you.